Hello, welcome to my YouTube channel. In this video, we are going to talk about a game changer in the world of microcontrollers and its installation. For those who have been using Arduino IDE for quite some time and are looking for a more powerful and efficient way to develop your projects, you are in the right place. So let's dive in. So for those who are not familiar with Arduino, Arduino is an open source electronics platform that consists of both hardware and software. So with the hardware aspect, you'll be dealing with single board microcontrollers that can be programmed to interact with LEDs, sensors, motors, and what have you. With the software, you'll be working inside a development environment so that you can write code to control your Arduino microcontrollers. So what can you build with Arduino? With Arduino, you can build health monitoring systems, you can build robots, you can build an IoT system to control lights, you can make music making devices, you can read data from sensors, you can connect to the internet, and then have your microcontrollers interacting. So Arduino is a great platform for getting started with electronics and programming. There is a large and active community of Arduino users who share projects, tutorials, and code online. So if you are interested in learning more, you can stick with me in this video as I take you through Arduino programming. But this will be with PlatformIO. Well, so what's PlatformIO? Simply put, it's a free and open source integrated development environment that allows you to develop, compile, and upload code to a wide range of microcontrollers. It is designed to be more efficient and powerful than the Arduino IDE. So what are the benefits of using PlatformIO? For beginners, PlatformIO might come to be a bit confusing for you. That's why I'm here. I'm going to teach you how to use the PlatformIO the same way you will be using the Arduino IDE. So PlatformIO is faster than the Arduino IDE thanks to its multi-threaded compiler. It also supports a wide range of microcontrollers, including the popular Arduino boards, as well as platforms like ESP32 and STM32. And with its built-in debugging tools, you can easily identify and fix errors before compiling. Alright, so before you can use PlatformIO, you will have to have the VS Code IDE installed. So let's go search VS Code. You select the first link, and then you will have this page loaded here. So whatever your operating system is, you have to download according to these. So you can just hit here, you have these, either a Mac user, Windows user, a Linux user. Alright, so for me, my distribution of Linux is Fedora, and I already have it installed. So after installation, we move to the next part of the video. Alright, so it should be looking like this on your machine. So you come here, when you hover it, it says extensions. So this is your extensions marketplace. So you search for PlatformIO, and then the first one looking like this. I don't know if I'll say it's an ant or an alien, but one of those. And then you install the extension. Alright, so once you are done installing the PlatformIO, you should see something like this. Alright, so you select the PlatformIO logo, you come to the PlatformIO home, select open. Make sure you're still connected to the internet. Alright, so let's create a new project. And we can say hello _ world. With the board, we will choose an Uno since we'll be using an Arduino Uno for this project. And then the framework automatically detects it to be Arduino. And let's finish. So it's going to take some time to set it up, but still make sure you are connected to the internet. So once PlatformIO is done setting up the Hello World project, this is how your Explorer should be looking like. Alright, so you open SRC, that's where you'll be focusing on writing code, and then you see main.cpp. Alright, so for those who are not familiar, include here is to put in the necessary requirements in this script so that it can run on your Arduino microcontroller. And then this is not part of the default stuff you see in Arduino every day. It's usually the void setup and then the void loop. Alright, so void setup is meant to run code just once, and void loop runs code multiple times. Alright, so I'm using a GitHub Copilot, and as you can see, it's suggesting code to me. So I'll explain what serial begin is. So serial.begin is used to initialize the serial communication to a set baud rate 9600. So see baud rate as the rate at which information is being transferred. Alright, so if your serial monitor is tuned to the same baud rate as your Arduino project, then you can see its output. But in a situation where my baud rate is 9600 and I'm dealing with or I'm using a serial monitor that reads 4800, I won't see readable characters unless I'm tuned to 9600 on my serial monitor. Alright, so next one, serial print line. So this is going to print hello world in my serial monitor. But I also like to set up an LED to blink. So let's do that now. So the variable name LED pin assigned to 13. So I've assigned this to pin 13. So it means anytime I type LED pin, the system will know that I'm referring to pin 13. Alright, so pin mode is used to set a pin to either input or an output state. In this case, it's output. Alright, so let's blink our LED. You come here, digital right sends high to LED pin. So high is, let's say, on, yes, and then you set a delay of 1 second, and then low goes off. You set a delay of 1 second, and then you are good to go. Alright, so how do we verify this code? We can come here, build. So it's compiling the script and building it. Alright, so took 6.68 seconds. Okay, nice. So now we are going to upload this code onto our Arduino Uno microcontroller. So as you can see, we have our Arduino board, we have our breadboard, we have our LED, our resistor, and then 2 jumper wires. So I'll share the schematic for the circuit diagram in the video description. So let's get to the circuit. So note, for LEDs, the longer side is always positive. So we are going to do that now. We connect the positive side to the resistor. Remember I said if it's on the same line for this side of the breadboard, then it's connected. So we can put one end of the resistor on the same line as the LED. Alright, so 1, 2. Now this line is connected to this line. Alright, so colors don't affect how the current flows, but colors is going to help you to identify which side of your circuit is ground, which side of your circuit is connected to a pin number. So same line, I decided to use red for the positive side, and then to use gray for ground. So on our Arduino board, as you can see, we have the pin 13 right here, pin 13, and in our code we assigned LED pin to pin 13. For the ground, we have about 3 grounds here, 1 and then 2 others here. Alright, so you can connect to any of your choice. Prefer to use this one. Alright, so our circuit is complete. Alright, so make sure to connect your microcontroller to your computer using this USB, and then you ensure that all your connections are well done. Alright, and then you come down here to the bottom left corner to upload your code. Alright, and then our code is uploaded. As you can see, whatever we wrote in our script is happening live here. Okay, and then connect your microcontroller to your IDE. You have to go and set up the port. One cool thing about this is auto detection. So as you can see, it has detected the port to be /dev/tty-acmo. And about PlatformIO and Arduino as a whole. Okay, so thank you for following. And then wait, I have to introduce you to the serial monitor. So you see the bottom here, if you hover, you see a plug or something. So let's hover. Yes, focused. So select that plug, and then this is your serial monitor. So as you can see, the script I told you to run once has been run. Hello world. Yes, so thank you for following. Catch you in subsequent videos, and then please do well to like this video, make comments, make suggestions to more videos you would like me to create, and subscribe. Thank you, and catch you in another video. Bye.